Today we'll be completing note 16.1, Intro to Sequences. So we are starting our sequence unit today, and what a sequence is a list of numbers or objects in a special order, so usually some kind of pattern. And so, for example, 1, the regular polygons form a pattern. So I have a triangle that has a perimeter of 6 inches, a rectangle or square that has a perimeter of 12 inches, and a pentagon that has a perimeter of 20 inches. And so what we want to do is write an expression that can be used to determine the perimeter of the nth figure. And so what this means is some unknown figure. So what I need to do is make a table based on the information that I have. And so what we're going to talk about is I have the first figure, the second figure, and the third figure. And so that's how we're labeling them. And it's continuing in a pattern to where I could find the fourth figure, the fifth figure, sixth, so on. That is what the nth figure means. You're looking for a unknown figure in some sort of pattern. Then the other information that I have is the perimeter. And so the first figure had a perimeter of 6, second one had a perimeter of 12, and the third had a perimeter of 20. And we just finished our regression unit, and so what we're going to be doing is actually using regression to figure out what kind of relationship does this pattern have. Does it have a linear relationship or quadratic or exponential? And so what you need to do right now is go to your list. So go to Stat, and in L1 we're going to type 1, 2, and 3. In L2 we'll type 6, 12, and 20. And you might have a guess as to which one it might be. You can look at linear and see that we're adding 6 and then adding 8. And so that's not a constant rate of change. So you may not want to pick that one first, but it's kind of up to you what you want to do. So we need to go through each one of these, linear, quadratic, and exponential, and see which one is the line of best fit. So I'm going to start with quadratic, since I just proved that it wasn't linear. And I get a perfect quadratic equation. Remember, if you need to turn on your diagnostic, what you're pressing is second 0, and then pressing the D button, which is the X to the negative first, and going down to diagnostic on, and pressing enter. So I'm going to go back and do my stat again. I'm doing a quadratic regression, and I get an r² value of 1. I can also do exponential regression, but if I'm looking at this data, it's not growing fast enough to be an exponential regression. And that r value was 0.996. So this is going to be quadratic. I need to go back to my quadratic regression and get that information. And so the expression, they're not really wanting the x, they're wanting it as n, or wanting it as an equation, but it would be n squared plus 3n plus 2. So this was my a equals 1, b was 3, and c was 2. So that would be the pattern to find the perimeter of the nth figure. So then I could use this to find the 20th figure or 50th or whatever number by plugging in 20 or 50 into n in this expression. So then it asks, what is the perimeter of the 7th figure? So I'm going to plug in 7 into the 2 spots where I see n. So 7 squared plus 3 times 7 plus 2, that is going to give me 72. And so the perimeter of the seventh figure would be 72. And so this formula gives me a really quick and easy way to find the perimeter without continuing the pattern over and over. Okay, let's look at number 2. So given a sequence in which a sub 1, and we'll talk about what that means in a second, equals 3, a sub 5 equals 19, and a sub n equals 163, what is n? So what you need to know about this is that a sub 1 means this is my first term. So this is going to be a common thing that you see throughout this Unit 16. So that sub number doesn't have any numerical value like an exponent. What it means is the first term. So a sub 5 would mean that's the fifth term. So basically what I have created here is some kind of table where I have the term number or its position in the pattern and then the actual number. So as in I have the first term is 3. I know that the fifth term, a sub 5, is 19. And I'm looking for the nth term, but I know that it's 163, but I don't know where that falls in that pattern. So this pattern here, if I was writing it out, it looks similar to this. Okay, so the first one is 3, then I'm missing the second, third, and fourth, and I have 19. So what we're going to do is we are going to plug this into our regression. So what you can plug in is these two terms, and I will give you a hint because the only thing that works with 2 points is a linear regression. We can't find a quadratic function or an exponential function with only 2 points. We have to have at least 3 to be able to do those. So it's basically telling me this is a linear regression, and so I'm going to plug these into stat and do a linear regression. So make sure if you have stuff in your list that you're clearing out the whole list and not deleting it. Then plug in 1 and 5 into L1 and 3 and 19 into L2. And stat calculate, and we are going to calculate linear regression. This is going to tell me that the rule is 4x minus 1. So what I know is that 4x, which really I should write it as 4n minus 1. 4n minus 1 equals this 163, but we don't know what this missing n is. But now we have a rule and we have something that it equals, and so I can solve this like an equation. So I'm just going to add 1 to both sides and then divide by 4. And what this will tell me is that n is equal to 41, which means that 163 is the 41st term in the sequence. If I could sit here and list them all out, it would fall in that position, the 41st term. So really the whole goal of this unit is to be able to make a table based on the data that you're given and to use our regressions to kind of figure out what the pattern is. So example 3 says Harold is starting a new workout program in which each day he will complete 4 more push-ups than the day before. If he starts with 5 on the first day, how many push-ups will he do on the 12th day? So I can create, again, a table with the number of days and the number of push-ups. On the first day, he completed 5. On the second day, I know that it is 4 more than the day before, so that would be 9. On the third day, it would be 13. You're adding 4 each time. When I have a constant rate of change in both my x and my y, we should know from 7th grade that that's a linear function. And so again, I'm going to use linear regression to figure out what this is. And with a linear regression, you only need 2 points. So if you only want to type in the first 2, you can, or you can type in all 3. And we're going to do stat calculate, linear regression. And the rule that I got was 4x plus 1. The question asked how many push-ups will he do on the 12th day. So I am plugging in 12 to figure this out. And I could have continued my table on. Probably wouldn't have taken me too long to figure out how many he would do on the 12th day. But again, we're learning this, so this is going to be 48 plus 1. And if I asked you for like the 200th day, that's not something you'd want to sit and make a list. So he would do 49 push-ups on the 12th day. All right, go ahead and turn to the next page. So this right here is just kind of an introduction to what we're going to be doing over the next few days. We're going to learn 2 types of sequences, an arithmetic sequence and a geometric sequence. These are 2 types of formulas. We have an explicit formula and a recursive formula. And these look really scary right now, but I promise it will get easier. But I did want to copy this chart inside your packet somewhere so that you have access to these formulas at home. In the classroom, where the orange formula charts are, there is a half sheet that is white that has arithmetic and geometric sequences on it, and it has the same formulas that are up here on the screen and in your notes. So if you need to grab one of these in class, you can grab one of those. I will let you use it on quizzes and tests. I do not believe these are formulas that you have to have memorized, because they are pretty crazy and very intense looking. So you are welcome to grab one of those formula charts. Again, it is underneath the orange formula charts. It is the skinny white formula chart with arithmetic and geometric sequences. But while you're working on your assignment or working at home, you can use this sheet that is in your notes. So you can either watch this video again on Schoology, or you can start working on your assignment.